I think it's okay.
It's okay. I can assume it's okay.
Thank you. You can share your presentation.
So it is in Turkish. I don't know which.
First open. First open. Second one.
Second.
No. Second one.
İptal.
It's great. Good morning, everyone. Let's start our session. The first is small to large proportional uniform distribution weights transferred to reduce energy consumption of training the models with fully connected layers. Could you please introduce yourself and start the presentation?
Sure. Close the door. What's the door? So thank you, Chair, and thank you, organizers. So my name is Farzad. I'm with the DMB Group, Data Management and Biometry Group in the University of Twente in the Netherlands. And basically, I'm working on the deep learning, energy efficient deep learning and scalable energy efficient deep learning. And I'm going to talk about my work, which is the proportional uniform distribution with the aim of reduce energy consumption of training the fully connected layers. Maybe click.
Watering.
What is the
It's a freezing. If you do it with this. It's on this block.
Okay, so I want to open the discussion with the problem definition, basically. It doesn't get on. Maybe it is work. So basically, in everyday usage, we are using the AI technology for different various type of aims. For example, I generate this photo basically using the AI, which consumes energy, and hardware resources. So, for example, training the ChatGPT consumed more than 10 gigawatt hour of energy, which is approximately equivalent to the energy consumption of more than 1,000 houses in a year. So it is really matter for both the training and also inference phase. So in the background, we have lots of efforts to reduce energy consumption, not necessarily energy consumption, but reduce the complexity of models during the inference phase and also during the training, which the training is my main concern in this work. And most of the previous works basically focused on reducing the training time, reduce the complexity or computation complexity, for example, the max or flux floating point, multiplication and accumulation and parameters, and so many other things. And the methods used are including, not limited, but including the quantizations. For example, we can reduce the data type from 32 bits to, for example, 8 bits, compressing neural networks or input data, pruning, which basically removes some parameters or make it zero, sparse training, which basically based on the very sparse matrix multiplication, designing efficient architecture, optimum hyperparameters basically, and also the transfer learning. So what about the challenges? To do this kind of stuff and reaching our main goals, the main challenge, including the energy consumption of convolutional layers, is much more than the fully connected layers. And this is main goal for so many previous literatures. Focus on the convolutional layers and not in the fully connected layers. And energy consumption reduction of the fully connected layers per se is a very challenging work, which I can also explain now. For example, the lottery ticket hypothesis is one of the most famous methods to reduce the energy consumption, but the authors claim that the method doesn't work efficiently for the fully connected layers. And another example is in the training of the AlexNet, we have 96% of the total parameters in the fully connected layers, but the fully connected layers only consume 28% of the total energy. So we have lots of parameters, but not much more energy consumption. So only talking about the weights or parameters is not enough from the point of the energy. If we want to talk about the energy, we should measure the energy consumption. And another important point, I will explain in the next slide. So basically, any effort to reduce the energy consumption should be less than what we achieve in the end. Otherwise, it does not make sense. For example, here, we tried to reduce the energy consumption from this point to this. So this is our benefit for the red, green, and blue one. So this is total benefits. And this is, the orange one is the total energy that we consume to reduce this energy, because anything we do, we need to consume energy. And our benefits is only this. So I tried so many previous works that they consume much more energy than what we achieved. So it is very important from the point of energy. And for the multi-layer perceptrons, in each layers, I will explain them in this photo. In different part of the training of the model, we have different energy consumption. So here you can see the feed-forward, back propagation, and update parameters for small, medium, and large models. So you can see when it is not, and you can here see the hidden layers size of the network. When the network is not too much parameters or small or medium size, the energy consumption approximately the same. But when we increase the model size and model parameters, the energy consumption exponentially increased. It is also the output of some previous works and also observed in my work. So you can also see the back propagation as the highest amount of the energy consumption and also the update parameters. So when we talk about the weights, not enough. We have also more potential to reduce the energy consumption. And regarding the feed-forward pass, it is also related to the batch size. Here you can see I use the different batch sizes. For the left is 128, and here is 10 times more batch size. So the increasing the batch size doesn't really affect on the update parameters energy consumption, but it has large effects on the feed-forward and also the back propagation. But increasing the total batch size actually can reduce the total energy consumption, because basically we need less iteration for training. You can see here that the total energy consumption reduced from 0.002 to less numbers, but with the cost of reducing the accuracy. So it is not per se enough. We need to do something else. And here you can see the energy consumption of the different layers of the model during the training. So for the fully connected layers, the energy consumption are directly connected to the size of the layers. Not exactly, but with a good approximation, completely in contrary of the convolution layers. Regarding sparsity, it is one of the famous methods to reduce energy consumption, which basically we try to make the parameters zero and try to ignore them during the training. But there are some challenges. If we want to exploit this sparsity, we need some hardware or accelerators, which we need to design them for our task. And also for using standard, if we want to use the standard hardware, like our laptops and so on, we need some specific hardware, software techniques to be able to exploit this sparsity. So sometimes the overhead of using the sparsity is more than what we achieve in the end. And yeah, the sparsity is related to so many different parameters like matrix dimension, sparsity level, and so on. So the aim of this work is to increase the model accuracy with low overhead. It is really important. So to reduce the total number of the iterations in the end. How? So basically, you can see here we have some weights and the corresponding loss. So the aim is to, instead of starting the training in the red point, which is based on the random initialization, we can start in the blue point using our method. So basically, we can reach to the final optimum method with less iteration, basically. So for the methodology is, we selected our model structure and size. So we try to train the model using the small size model, which consumed much less energy than the larger model, and try to transfer our learnings to the larger model using the uniform proportional distribution. So actually, I used various type of distribution, but this was the best. And after the initialization of the larger model, we normally started to train the model, but basically with less iterations. So the basic idea of this work is when the total model size increase, the energy consumption also exponentially increase. So if using the left oval here, so basically we have very low energy consumption. So it is not our favorite, but when we're dealing with the large models, so basically with a little bit reducing the model size, we can reduce a lot in the energy consumption. And this is the base concept of this work. So we're trying to train a small model with low energy consumption and train the larger model to reduce the total energy consumption. So about the experiments, I directly go to the results. So in the left photo, you can see basically we started our model. This is for our method, and this is for normally trained the model, for blue one. So in the both methods, the random initialization accuracy is very low, less than 0.1. And in the blue, you can see after some iteration, we reach the final accuracy, which is nice. But using our method, first we start to train a small model. And here, after even only 2 epochs, we reach to this point. And using the weight transferring, we reach to this point, which you can see the weight transferring act very good. So we accuracy dropped only from 0.88 to 83%. So the efficiency of the transferring the weight is really good. So instead of initialization of the large model from this point, we start the initialization from this point. And with less iterations, we reach to the final point. And here you can see, in the right photo, you can see a little bit zooming. The final accuracy of the model is much better than the normal starts to training the model. So in this case, in all of this case, we stop the training the model when we reach the same accuracy. So basically, we can conclude that if we want to reach the same accuracy, we can consume less energy than the normal. And this is a different energy consumption of the part. This is for a small model, which basically consumes very low energy. And in the second one, you can see the large model, which we initialized using the small model. So the total energy consumption of training the both is less than when we only start the large model from the scratch with the same accuracy. So basically, energy consumption reduced. So to be able to generalize this method, I also tested on the different model sizes. So I changed the model sizes, and in the left, the same approach and same happenings, and in the right, you can see again this method works properly when I change the model sizes, and the final accuracy is better, or the energy consumption reduced. And for different model structure, till now I use the same structure for the model training, but here I also changed the model structure and also the size. And again, you can see the final accuracy is better than the normal. So the works is also, this method is also valid for the different structure of the models. I also tried to apply this method on another platform and in other packages. For example, Keras or TensorFlow is one of the package or libraries in the Python, using the Python base, which their efficiency is really good. Basically, the energy consumption of the Keras method is really better than my code because they have a really better backend. I also tried to apply this method to this package, so it also worked the same. So the final accuracy was better and total energy consumption reduced. So basically, this method can be applied to any packages or any libraries, and it's not actually limited to the specific War codes. And till now, all of the models that I tried, the larger model had the better results from the point of accuracy than the smaller model. So in this case, I tried to test it on the different case. Opposite case actually, when the small model had less efficiency to reach the final accuracy than the larger model. Basically, the small model doesn't have this potential to reach the larger model. So, and this is a reason you can see in the left photo. The initialization here is not very high because of this issue. But again, in the end, when I use this method, the final accuracy and final energy consumption reduced. So which means that this model is also applicable in these cases, but this is very, very critical points in the reality. So it's rare this case. And to test also the different data type, I also used the CFAR. Till now, I used all the simulation that I showed in the MNIST dataset, but CFAR basically we have lots of more categories to classify. So you can see in the orange one, during all of the training, the accuracy is much better than when I use without this method. And the final accuracy is also better, which means the energy consumption improved with the same accuracy. And as a conclusion, so in this work, I tried to investigate an energy consumption of training the NLP model for the fully counted days, which is very challenging. And the main aim is the better initialization of the large models. So basically, I tried to use the one distribution, which was very effective on this method. So I used the training small model with a low energy consumption, very low energy consumption, and based on that, the basically transferred to the larger model. This proposed model has tested under various scenarios to test its applicability and also to generalize of the model. And the proposed method has better efficiency in comparison to this, training the small model or large model from the scratch. And efficiency of this method decrease when we are dealing with small model versus the large model, but we can apply method on different packages like Keras or any other methods. And as the future works, I observed some fluctuation during the training, which reduced by basically the efficiency of method. So using some hyperparameter optimization can improve this efficiency, actually, I can say. One of the good choice for that is using the learning rate. I observed that when I increase the learning rate, I don't need the small learning rate when I started the new initialization instead of the random initialization. So when I increase the learning rate, both the speed, energy consumption reduced, and also I observed less fluctuation. But what exactly optimum parameters needed? So it depends on the optimum. So we need a new method for that. I also have a backup method to compare this method with the another or other methods. So I can also see this method works better than the other methods I use. For example, using the structure pruning, using the sparsity, and so on. So basically, this is my final point, and thank you for your attention.
Thank you for the presentation. Actually, research is interesting, and it is one of the most important things that we should do is to reduce time context. Uh, for your research, I noticed something. Could you please return back to the
So which slide?
yeah, this one, for example.
Yeah.
You can see there's a drop in 3, and there's another drop in 8.
Yeah.
While when you train with the regular, you can see it's logarithm.
Yes.
So can you explain these
Yeah.
points?
So basically, it is a small model train.
Okay.
And not a large model. The blue one is for the large model that we have from starting to train it from the scratch.
When you buy small model, you have a small number of samples.
No,
Or small model, it means that you have different structure for it.
same structure, but for example, the lower amount of the number of the weights in the layers, but the same structure. So it is a small size. So for example, here, this is the total number of the weights in the hidden layers, which less than this small. So this is small model, but with the same structure. So
But if you said that you are doing fully connected,
yeah.
you have, for example, 5 inputs, 20 individual, another 20 individual, and then let's say it is, let's say 3 another output.
Yeah.
And for the reduced model, you are using 10, 10. So how could you initialize your weight? In this case, it's a different number.
Yes, but actually we adapt the difference. Here I explain.
I mean, the weight matrix has different size.
Yes. So basically, the input and output layer size is the constant. We didn't change it.
For sure.
Yes.
The middle is the most important.
Yes, exactly.
Okay.
Exactly. So here, this matrix is a different size with this.
Okay.
So this is our matrix, large matrix, and this is for a small one.
Okay.
But how can we, for example, this is one value, but here we have 4 values for this corresponding, right? So we try to distribute this amount to the larger matrix to be able to initialize it. So what the method used, the proportional distribution I tried. So basically we divide this number of values here for the small model to the larger models. So with this case, yeah, it doesn't really matter. We have the same matrix size because we transfer the weights to the larger matrix.
But actually, you are not using the accurate initialization points. You are using approximate.
Exactly, but
Because you are using one value to replace 4, for example.
exactly. But here, for example, here, in the blue one, it is a normal large model. So it is the random initialization, which is less than 0.1. But here, using this method, it is an initialization of the larger model at this point. So instead of initialize this, we have initialize with this, which is much better than. But with a very low energy consumption. So in the end, we need much less iteration.
Okay. So you are only counting on weight initialization to reduce consumption, and later on you will carry on for the learning rate.
Yes. Basically, I didn't do that for these outputs, but when I change the learning rate, some fluctuations improve, and also energy consumption
For
grows.
sure, it's
Exactly.
really improved.
Exactly. But what is the optimum point? It is, I guess,
It's
the future.
different based on the data. Which type of data you did your
The input data.
yeah.
Yeah, here of NNIST, and in other scenarios, we also check the C410, which is, I need much more iteration for that.
Any questions?
Just a minute, question. You were showing the trend of energy consumption, which was exponential.
Yes.
But if is that because the computational complexity of this kind of numerical problem with this exponential cube, or what?
Yeah, so basically the main reason is I use normal laptops with the standard hardware. So when the total number of the parameters increased, so basically first we use the memory inside the processors. When the memory is get full, so we go to the DRAM and started to fetch the data from the DRAM to the processor. And when again it is full, we go using the another level of the memory in the hardware. So the most important point is the computation consumes less energy than the data movement. So this is the main reason that when we increase the total number of the parameters, total number of the data movement increased, and this is the main reason that the total energy consumption exponentially increased in comparison to the lower amount or small size of the models.
Thank you.
Thank you very much.
Thank you so much.
So, can I ask you the conversation of another guy from room B? He is a chair in room B.
Alexander? What's this one?
Sandra he told me to ask you where these glasses.
Oh. This one? Okay. For the next presenter, Bert and Girl. Can you
So, there's no other session.
I don't know which is yours.
Which one is yours?
Which was the yours?
Which one is yours? The first one. The first one is.
Okay. Where's the tab here?
Tab is this one. No. Oh. Display. I don't know. Display settings. No, not this. It should do with this. Oh, can get.
It's okay.
Do you want to remove this, right?
No, I want to share it.
Oh, sure. Share it from here. But sharing is from Jitsi, right? Not from here. So, where? Whole screen. This one.
Yeah, it's okay. Thank you. The next research is review of comparative studies on performance evaluation of communication mechanisms for micro services by Eric and Beryl. Could you please introduce yourself?
Okay, thank you so much. I'm the second author, Birol Çilovgi. I am from Ege University, Department of Computer Engineering, Izmir, Turkey. So we are going to present you a survey of actually the studies conducted for communication of microservices. By the way, Berkcan Çiftçi is my master's student, so this study is conducted as part of his thesis study. And we wanted to, first of all, observe and see what the most famous or more popular or commonly used technologies and benchmarking tools are. So we wanted to check the studies. And just a second. So this is the outline. At first, I'll start with a brief introduction of the research questions, and then the related work, the related studies we have examined, and then the findings and discussion and conclusion sections will continue. So as I said earlier, we checked three different aspects related to microservices. The first one is the communication technologies utilized in each study. The second one is the benchmarking frameworks employed to perform performance analysis. And finally, the performance evaluation metrics utilized for each study. And our focus was on inter-process communication on microservices. So these are the research questions. As I told earlier, the first one is on the utilized technologies. The second one is on benchmarking frameworks to perform these performance evaluations. And finally, the metrics utilized or leveraged for each technology. And these studies are the ones that we have seen. So it starts with the year 2020 and goes to 2024. There are a relatively limited number of studies. All of the studies compare the performance of at least two technologies. Let's check the slide a little bit more. Just a second. Okay, sorry now. Okay. So, which technologies are utilized was the first research question. I think I can show you first of all this table. So you can check the studies and the technologies utilized in each study. First of all, HTTP REST, HTTP2, gRPC are the synchronized technologies utilized. And then there is GraphQL, MQTT, AMQP. These two are low-level standards, especially utilized for IoT applications. And then there are a lot of message brokers that are very popular for microservices like Kafka, RabbitMQ, NetStreaming, RapidMQ, Pulsar, Redis, ActiveMQ, Alchemist, and finally WebSocket technology. So here you can see which ones are more commonly used than the others. So when we check it as a complete figure, we can say that RabbitMQ and HTTP REST are the most popular ones, which has been compared in 7 of the 12 identified studies. And then Kafka is utilized in 6 studies, gRPC is utilized in 5 studies, and Redis is utilized in 3 studies. By the way, we only showed the studies utilized in 3 or more studies in this figure. So if you check the table here, the rest are used in 1 or 2 studies, such as one here, just 1 study, 2 studies. So this is the answer for research question 1. And then for research question 2, we checked which benchmarking frameworks are utilized to perform performance evaluations. And as you can see, 2 of them use no benchmarking framework. So they were like a detailed technical analysis without performing any actual technical analysis, let's say. And among the other studies, Apache JMeter is the most famous one, or the most popular one, utilized in 5 of the 12 studies. And then at the second, we can say that Open Messaging Benchmark Framework is the second because it's used in 2 studies. Finally, there are 3 different custom benchmarking tools developed in separate studies. So we categorize them as 3 here, but each of them are different benchmarking frameworks. So instead of using these two commonly available ones, those studies developed their own benchmarking tool. So in this table here, you can check which study used which benchmarking framework. So operator geometry, as I said, is the most popular one, utilized in 5 studies. And custom benchmarking tools were developed in 3 studies. An open messaging benchmarking framework is utilized in these 2 studies. And no benchmarking were done actually in the first 2 studies. Those are the relatively old studies from the year 2020. And for performance evaluation metrics, this is actually the answer of research question 3, but we got this from the paper, so we didn't want to change it. I'll talk about it here. So the performance evaluation metrics utilized in each study are also examined, and here we listed metrics utilized in 2 or more studies. Some metrics are utilized in just 1 study, but we didn't show it in the figure. So as you can see, throughput and latency are by far the most popular metrics used in those comparisons. And then response time, availability, CPU utilization, memory usage, memory delivery guarantee, message persistence, message ordering, and scalability follows them. So here you can see which study employs which performance evaluation metric. And also we have a detailed representation here. So each study utilizes which metric. And we also show the other metrics here, which has been utilized in just 1 study. So that's how we represented them as a figure. So when we analyze all of these findings together, we can say that we had 3 research questions. We checked the communication technologies, benchmarking frameworks, and performance evaluation metrics for inter-process communication in microservices. And we have identified the most commonly used ones. There are synchronous and asynchronous communication technologies. If I came back to here, just a second. HTTP, REST, and gRPC are synchronous technologies, so they are really popular. Among the asynchronous technologies, RabbitMQ and Kafka are message brokers, and they are really popular. Redis is a NoSQL database, which can also be used as a message broker. So in these studies, it's used as a message broker. It's also popular. So when we check the conclusion part, we can say that both technologies, synchronous and asynchronous, are really popular and compared in many studies. Some of the studies, actually, most dominant studies are conducted on synchronous and asynchronous technologies together. However, some of the studies conducted performance evaluations for only message brokers. So no synchronous technologies were involved in them. We can also see them here. For example, these 2 studies, there are no synchronous technologies utilized also here. So they just compared the asynchronous technologies, message brokers. These 3 are the commonly used synchronous technologies, as I said. On the other hand, there was just a single study which focused only on synchronous communication protocols. So as another insight, we can say that synchronous technologies are ideal for low-load immediate response scenarios, while asynchronous methods are like message brokers, like these 2 popular message brokers, are utilized for high-load and fault-tolerant systems. These are the technology aspects. We especially focused on the technology part. When it comes to the benchmarking frameworks, operator geometry is by far the most widely used one. And for the performance evaluation metrics, again, throughput and latency are the most popular ones, with 10 and 7 studies each. For further research, we can say that we can focus on hybrid communication architectures that combine both of them. so that we can address the strengths and weaknesses of synchronous and asynchronous methods. On the other hand, we can also integrate machine learning techniques to dynamically optimize which communication framework can be used on which scenario based on the workload patterns, so that we can enhance the adaptability and performance of the communication structures. And finally, we can also perform some case studies for edge computing and 5G-enabled IoT environments. By the way, there was just one study focused on IoT environments. So it's also part of a possible future work. Thank you. Do you have any questions?
Thank you very much. Interesting subject. Could you please return back
Sure.
the measurements, the performance measurements? I just want to ask you from curiosity point of view, why do you think they are all focusing on throughput majorly?
I think it's because when they communicate, when the microservices communicate with each other, so checking throughput is like the most essential or the most logical scenario, because it's like the amount of message you deliver by time. So it's like the
most important
yeah,
indicator.
the most basic or the most important indicator. You can say it that way.
So is it different for asynchronous and synchronous to use measures? For example, some measures are preferable in synchronous and others in asynchronous.
Yes.
I'm just
No. There's no distinction like that. They can be used in both studies actually. You can check this. For example, throughput is available on here, or it's available here. So throughput is not available only on 2 studies. It's available at almost all of them.
Yeah.
So it can be utilized in.
So there is no specific
No.
measures for recommended for synchronous or asynchronous.
No.
Thank you very much. Any questions?
Okay, I can like finally say that after conducting this study, we are conducting a new performance evaluation of our own, and in order to do that, we get the insights we got from this survey. So we are going to use the Apache JMeter framework. Actually, we started and we are getting some initial test results also. We are using Apache JMeter, and we analyzed the 5 studies conducted with this. And we analyze the technologies utilized with them and the performance evaluation metrics. So we are planning to cover all of the metrics and technologies conducted with it, so that we can provide more insights on the Apache Method
So this
framework.
is the first step of it.
Yes.
Thank you very much.
Thank you.
The third presenter, Ahmed. Hi. It's all yours.
Yes.
Okay, the next research is the predictive model of trust and risks of S-MERS by Ahmed Shahaber.
Correct.
Okay, could you please introduce yourself
Sure.
before starting?
One second. Let's make sure. Yeah. Right.
My name is Ahmed Shaiba. I originally come from Jordan, but I'm associate professor at Zayed University, Abu Dhabi, UAE. This paper is part of a collaboration project that has started 2 years ago, and I think this is probably the last paper of the project. Before I start, Do you all do social commerce shopping, like Instagram shopping, WhatsApp shopping, Facebook? No? Thank you. You do this? Girls? Lovely girls? Any, no? Never. Okay, that's interesting. Because it's becoming a norm now in the EU, by the way. So why not? So why you don't do shopping on Instagram, for example, or Facebook?
Don't trust.
Oh, so it's a matter of trust then. Okay. This is basically our focus here. Is trust and risk are correlated? This is the first one. And the second, that is more complex. Which trust dimension actually you are worried about? Because trust has 4 to 5 dimensions, by the way, as per mathematics models. So why we don't trust? What was the layer of trust? And then what breaks this trust? What sort of risks that might be there with the social commerce? So this is basically our focus here. So e-commerce is basically blending e-commerce with social media. It's becoming now a norm in the EU. By the way, worldwide, the first platform is Facebook, then becomes Instagram, followed by TikTok. UAE-wise, it's not Facebook. Do you use Facebook?
Yes.
Not in the UAE. The number one is Instagram, and then becoming TikTok, and afterwards is WhatsApp. And there's a huge shift, especially from Generation Z towards social commerce when they are dealing with shopping rather than just going to those malls. They still go to malls, okay? But they would also prepare and spend more time having on the social media. One student was telling me that the product is finding me on social media. I'm not the one who's finding the product. It just pop up. Just whenever I scroll down, it just appears. This is it. And sometimes it's by voice recognition, sometimes by textual conversation. This is some sort of linkage of search engines. So the problem, we don't trust, but we don't know why we don't trust or what trust dimensions that lacks. And then how it's relevant to the perceived risk. What sort of risk? What you are worried about? Can I ask you this? What are you worried about? Like if it is cheaper and more easier, convenience, while you are sitting on the couch, you can just click.
Could be scam.
So it might be security then. It might be
Low quality.
Not the quality.
and quality as well. I might lose my money. I don't know probably the merchant. It's sometimes it's time risk, and that happens many times, most often, especially during Eid breaks, holidays, while people need their stuff to be received just before Eid, and then it's not received, it's not delivered for some reason. So that time risk is really a big thing there happening, especially if you have an occasion or you're traveling and so. So we need to look carefully about those deep insights of trust and risk. The problem with the literature is that they deal with trust as one construct, one variable, without identifying the dimensions inside. Same with the perceived risk. They deal with one certain construct without the types of risks. What sort of risks that influence what dimension of trust? This is basically my objective, to measure what risk is affecting what trust. Okay, sure. And I'm using Generation Z because they are spending more time. On average, they are spending at least 3 hours using social media a day, regardless for shopping, for browsing, for communication, for whatsoever. This is the latest in UAE. 3 hours a day. And guess what? My students spend more. And I asked them if they wish to voluntarily share how many hours they spend in social media. And they just give their mobiles, you check. It's like 5, 6 hours, 7 hours, 8 hours. So 3 is nothing. That makes the possibility of doing shopping, of course, more high. So this is the gap. Again, what the perceived risk is impacting what trust, so that we can predict that trust. Literature, again, dealing with trust and risk as constructs, not as dimensions. So we all know that there is a trust issue, and we all know that there is perceived risk. We don't know the correlations, the inner correlations, okay? That's what we lack. It's done in e-commerce, but it's not done in s-commerce. So there are several attempts of trust and perceived risk in a shorter level, but in e-commerce, like website, not in social commerce. But again, this is a different arena. So this is basically the summary of the literature. My method is a quantitative approach. I shared a survey with 320 students from my university on campus, Abu Dhabi campus. And that was an online survey. We have that perceived risks and all trust dimensions. We have 5 different variables. Each one has from 3 to 4 dimensions, like 3 to 4 survey questions. And then using a software called Smart PLS, and the method is partial least squares, structure equation model, if you are familiar with. So this is basically for multiple regression. Okay, it's a multiple regression model. This is the model. So we assume that the financial risk has something to do with the merchant integrity. Integrity means honesty. And then financial risk might have an impact on the merchant competence, whether they are able to fulfill their promises. Security risk might also impacting integrity, and competence, same for time risk. So these are the risks, and here's the trust dimensions. And let's then together and see which regression path is significant and which one is not. Okay. So I need to hypothesize that everyone is impacting all dimensions, and we need to discover because we don't know. Initial screening I did. Are you familiar with multiple regression? I hope so. Thank you. Okay. No worries. For smart tailors, for regression, how it works. First, it starts with what's so-called the outer model, and then it goes to the inner model. Outer model, it means we need to check the validity of the survey items, whether it really measures those constructs, those variables. And this table is not here, actually, it's available in the paper. It's called item loading. So all item loadings were above 0.6, which means valid. But then we need to move to the second one, that is the reliability and convergent validity of the constructs. For every construct, we need to check Cronbach alpha. That's for the reliability. And the AVE, average variance estimated, for the validity. So this what tell us that this model is valid. This model is reliable, you can proceed further. And the threshold, the cutoff point for Cronbach alpha is 0.7. As you can see, it's all above 0.7. This is like not so good, but still acceptable. And for the AVE, it should be all above 0.5. It should be valid at least 50%. And again, this is good. By the way, I was a bit worried about this. This is just at the threshold, but again, this is fine. This is exploratory factor analysis, so I don't know this. So it's not like a confirmatory. No one has used this before. Another validity that's called discriminant validity, which this is Fornell and Larker criterion. All the values in the diagonal should be above the values down, so that every variable validity is more than the correlation with the other one. This is called multi-correlation table, okay, or the heat table. So as you can see, all variables, this one is higher than this one is higher than this one is higher than this, and that means that there's a discriminant. Okay? They are different. Okay? And then the last table for the analysis, it shows everything. It shows the path, it shows beta, and the power of that impact by t-statistic, the significance by p-value, and whether my hypothesis is supported or not. Surprisingly, all hypotheses were supported. I wasn't expecting this. It means every single perceived risk dimension is impacting the trust dimension. It means there is a multi-complex relationship among the model. It means all risks are hitting or impacting the trust dimensions. And honestly, this is a big thing. Because again, I wasn't expecting all hypotheses to be tested and need to be accepted. As you can see, with the highest impact, it goes for this one, security. So security impacts the merchant competence. So if I have high security risks, like scamming or I don't know the merchant, then it will definitely impact how I see the merchant is competent or not, is able to fulfill the order or not. This is by far probably the most impactful. So security on that's why part of the implications that they need to work on this. This is the most influential. So these are main findings. I wouldn't like to go further with the stat. Okay, so security is the strongest hit. Financial and time risk actually is all about integrity. This is when it comes to the other trust dimensions. So again, trust is multifaceted. Trust is not one thing. Trust is different dimensions. And we need to look at it again from those different dimensions. By the way, I intentionally dropped 2 trust dimensions. I haven't tested them, and I'm leaving them for future research. That one is called benevolence. Like if the merchant wants all good things to me. Okay, I dropped this by purpose because it's not relevant here. Here's some sort of discussion again. All results in this paper are considered genuine because no one is looking at this deeper sides. So security first when it comes to social media and shopping, and then about delivery, because it's definitely very important, especially when it comes to time risks. Also to engage Generation Z with the customization and with the conversation with the merchant, and this is what put them on the labs. Also, it's about the platform design and aesthetics. Sometimes they tend to trust the most probably aesthetic layout and nicely designed Instagram pages rather than anything else. Although it might be scam, by the way, but we tend to trust those nicely designed interfaces. Okay, I tend to do more, again, to engage more trust dimensions if time happening this part of the future world. So for now, we were dealing with only Instagram, but we have no idea now. TikTok is booming at TLE, so we don't know whether the same thing is happening there. And also with Snapchat. Also, we were just looking for the Generation Z, so we don't know probably our ages, how they perceive this. Might be different. Additional risks, again, like privacy. Privacy sometimes, or most of the time, is included in security, by the way. They call it security and privacy. That's why I'm not really concerned. But we probably need to check maybe the culture. Like if we do the same study in Turkey, do you think we will have the same results? We don't know. And then probably longitudinal, like over time survey. Probably if we do this like after 4 years, do you think we'll have the same results again? We don't know. Thank you so much. And let's please communicate here. You can, under this QR code, you can find my webpage. And my pleasure to handle your questions. Please.
Thank you for an interesting talk. My question is in the data analysis slide. Why all the p-values were shown?
Zeros.
Yes.
It's not zero. It doesn't come to be zero, by the way. It's less than 0.000. That's why we just put it zeros. The software generated as zero, but it's like 0.00001. Okay, but that means it's highly significant. The cutoff point here is 0.05. Whenever it's less then 0.05, it means it's significant. But if it's like 0.0, then it means maybe 0.04. Okay? So it is calculated to be less than 0.00 something.
So I have another quick question.
Please.
So basically, you try to find some correlation between different concepts. So it's also possible using the deep learning to find this.
Correct. It depends now on the method. We need to switch. And this is, by the way, my friend's project. Instead of having the survey data from survey, we have the data set like from a real social media, and then we can deploy this model. Right? Because the regression is there, the relationship is there, the features are there. So we need now a huge data set. And by the way, we started with, when it was Twitter, it was like 2 years ago. We had like 10,000 tweets, and now we are working on like 80,000 from X platform. And then maybe we can try on Twitter, because the data set is not obtainable from Instagram and not from my Facebook. They are not collaborative when it comes to data. But now, after Elon Musk, we can still get data from X, Twitter. However, we need to pay them. It was for free.
Thank you.
Please.
Like your results, where you can imply them, so you take the advantage, like for companies, for Instagram, or for you?
Yeah, definitely for both. This is to know at least that we as humans, at least to know why we don't trust and what's really affecting our trust.
Like sometimes you do stuff and you don't know why, you just don't care. Like I don't shop, that's it.
Correct.
Like if I will see reviews very, very good, even from the people I know, I will know that this security risk will go away, because like it's like even when you shop online, you look at the reviews from actual photos, not from the marketing photos, from reviews. So technically, like user review, how this will be really useful for the future,
Correct.
for companies or for.
If, I'll answer them in 2 sections. First one, if I would like to extend this to make it more meaningful to users, I would extend the model to have one other construct, that is the intention to use, or the continuous intention. How this trust is either raising or decreasing my usage to social media. So we need like another construct. Because as you said, we might not trust this, but we just use it. For whatever reason, it's cheap, or it's little risk, or it's really good offer. Let's make it try. It's fine to lose probably 200 lira.
200 euro.
Lira, not euro.
Yeah, okay.
Lira. Sometimes it might be fine. So yes, it might not be trustworthy to me. However, I'm still using it for whatever reason. Cheap, time, but as you said, high reviews, recommendation from someone. It's fine. So for me, we need to continue the cycle. And by the way, this is another model. It's on there. I've published probably more than 10 papers in this topic so far. So we are taking it from different perspectives. Every time we're trying to dig more details to understand some hidden patterns. So for me, I need to understand whether this is really hindering my using. But the second thing is that this is important for the platform, for Instagram. They need to know how the behavior of merchants is affected by what sort of risks. Because if many people is shouting and complaining regarding the time, for example, and the late delivery, they need to know what's the impact then on the merchant. And otherwise, people won't be probably dealing with not only with the merchant, but also with the platform itself. They consider that Instagram is not really good for shopping, although it's like the behavior of 2 or 3 merchants only. So they need to consider this. They need to set some policies, rigid rules, regulations to manage this. Okay. Thank you. Please.
What do you think the main differences between e-shopping and now X-shopping?
Excellent. E-shopping is where you visit the electronic shop, the website, and you go there. So you are prepared to do the shopping, and you are targeting one website or one platform that you really know it's the merchant. Social media, we're having on Instagram and TikTok, someone is saying, wow, this is nice. Please try it. I don't know who is the person who is trying to do that ad. I don't know about the product, but then I just click, yeah. let's contact on WhatsApp. How much? Like pay money? Then yes,
Okay.
cash and delivery. This is it.
I got curious. This project, like, it was your idea, or maybe like a company asked you? It's like, where does this come from?
No, this is funded by Zayed. This is my idea. This is my idea. And I'm working with a colleague actually, with the two parts.
Yeah, I mean, like, maybe later you can sell it to merchants to the production.
We are working, by finalizing this project, we are working in one very big model to see the entire picture, because now we are splitting them into parts and then we're putting one. But then it's not going to publish anywhere because the results are already there. So this is like to conclude from our universities that we came up with this one very big model, and it's for internal publication, not for external, because it's done. Thank you. Thank you. Where's the class, please?
Okay, we can continue with the next presentation.
It's me?
Steaming power?
No.
No?
No.
Steaming power, empowering migrants through inclusive STEAM education introduction. Education is a lifeline in the migration crisis.
So
That's
now I have to and as well show.
Who is the last presentation? What presentation? Sarah Ali?
Okay. And now, how can I share my screen?
Who's already sharing? Go to Google Chrome.
It's okay. Yeah.
Are we sharing the screen online also?
I assume.
He started. Just a second, so can you share? Should see.
Okay. That's one. Hi, I'm Andrea Lombardi from the University of Perugia, and my talk is not a talk about science, and which is an exception for me, because usually I'm a research talk. But in this case, I want to talk about this project, cooperative project, which is about education for migrants, and it is co-funded by European Union, where this migrant issue is a very important current problem. And the acronym is quite complex because it comes from this phrase, which is the STEAM approaches of higher education for migrants, refugees, and asylum seekers empowerment. Okay, STEAM empowerment. And let me describe the no. Okay, I'm stuck. Mouse.
I think it should be okay now. Yes.
Okay.
You can either do this or
Okay, I can do it. Let me just give you description, a snapshot of this project. It is, let's say, a pan-European initiative that it is meant to improve the situation about educational exclusions between migrants. And the approach is based on some pedagogic methods, and it is the core of the project. It is the virtual learning environment, which is the instrument that should allow us to reach migrants and to include them in terms of education at a higher educational level. And let me cite some reaching of this project activity. For example, during the first pilot year, project reached 6 refugee camps across the various countries, and 1,300 hours of instruction were delivered somehow, and 1,500 participants received a certification for their activity. And no, the consortium who managed this project is all over Europe, more or less, and it is. I can mention some institutions. For example, there is my institution, University of Perugia. From Greece, there is the Middle East Technical University from Turkey, and Aristotle University from Greece, Cyprus. Some also NGOs are involved, of course. There is Fundación Solidaridad from Barcelona, and this institution contributes with different expertise, very diverse expertises. For example, my institution contributes in terms of computational chemistry, which is not directly about education, but it's useful for many reasons. Aristotle University is specialized in climate modeling, climate science, and you will understand why this specialization. University of Minho in Portugal is about sustainability science and so on. This is the consortium, and let me give some motivation and some numbers about the lack of inclusion in education of migrants. According to official statistics, globally, people access higher education at a rate of 37% globally. Okay, of course there are differences according to geographically, but global is 35%. And what about refugees and asylum seekers and migrants? Well, the rate drops dramatically at 3%. Almost no one among migrants access higher education, and this is a problem, of course. But why this situation? Because it is very difficult for them to access the project a higher education track. Because imagine a Syrian teenager, for example, that loses 4 academic years in transit in his country, for example, for some reason, or people from African countries that didn't get a diploma recognized in Europe for many reasons, or in the average situation is that these people that usually it's very young people, they have a very fragmented educational record. So there is a barrier to access higher education, in fact. And this is the problem. Civic power, how can we contribute to mediate this situation? Well, the idea is, for example, it's that we have to create a way to establish a way to make higher education accessible to them, and the idea is to break somehow the curriculum to micro modules. Okay, and why? Because this is very useful when we want to implement these modules on a virtual learning environment. Okay, so this is a typical technique. Also, we had to care about languages. So the project take care about at least six languages: Greek, Portuguese, Italian, Turkish, Spanish, but Arabian too, and some other many other languages. And this can be done in a virtual learning environment more easily than in person, as you can imagine. And what is the focus? What is the subject of this education? Well, according to European priorities, which are the well-known green transition, transition, climate change, sustainable development, we decided to focus on this in terms of content. Let me further on. Let me give you some more numbers. Well, according to official data, around the world, at least 300 million people live outside this country of origin. Okay, and of this, 26 millions are classified as refugees. Okay, and another fraction, 4.2 million, are just asylum seekers, so they are waiting to be classified, let's say, as refugees. The Mediterranean area is impacted heavily by these migrations, as you know, and just considering the Mediterranean, I mean the sea between Iran, Spain, and the rest of the world, let's say, more than 1 million people arrived since 2015, and of course only 3% of them have higher education. This is a trend. Here you can see the jump, for example, starting from 2010, and this is the situation about the numbers. The target of the project is not kind of people, but more specifically teenagers, aged 15, 18, let's say, and women. Okay, because these are the more fragile categories, in the sense that they have to face barriers. For example, females are always in a more delicate situation. Imagine, for example, a counselor. There is a gender bias situation because they have to face many difficulties. For example, they to take care of children. For example, they have reduced expectation about eventually salary or a job and so on. So we have to take care of this in terms of inclusion. Okay, this is for especially for women and for young people, teenagers or something. Okay, so learning must be inclusive, and in projecting the learning offer, we took care of this aspect very carefully. Another social and economic aspects. The European Commission is foreseeing a shortfall of 1.2 million skilled professionals. I mean, people who have skill in science, technology, engineering, mathematics, and so on. No skill. By 2030. Okay, everything is by 2030 now, as you know. And this is a risk for Europe because it can inhibit in transition and digital transition and so on. So part of this short part can be covered maybe if we act quickly and effectively against this low access of minors to higher education. Okay, so this is another motivation for this kind of projects. I don't know because why. Okay. Yes, now it's okay. And there is another. This is another way to motivate this project, which is more related to the famous global goals of 2030 agenda, and two of them are specifically number 4 and number 11 are about quality of education and sustainable cities and communities. Okay, so this is another reason why we focused on the reducing the education gap for these kind of people, and why we focused on sustainability, climate change, and society. Okay. If you like it, I can show you a diagram, hero change diagram, who shows visually how we start from the problem. We input some. This is the action that we want to perform. This is the methods, activity, development of STEAM skills, and through this flux we can reach our desired objectives. So we have to act in many under many aspects. There is our virtual learning environment. There is the multilingual dimension of this instrument. There is a strong effort about mentorship of integrators to reduce exclusion of women and young people, and this is the flux to reach the results. This is the program structure. Essentially, the activities are based on events, okay, and standard formats of these events that are organized involving migrants, okay, so contacting the NGO and they provide migrants, okay, tens of them each time. The standard format is 2-day introductory course, which can be online or in presence, and then there is a 5-day still intensive course. These events have been organized in different places by the partners, and this is a more detailed description of this event. There is a total of 7 days in the learning sequence, and but there is a 2-day event which can be also online, where learners are invited to complete orientation modules, for example, on digital literacy, civic awareness, storytelling, which is an instrument that is very useful to the few people. So they are taught about what storytelling is, and then they are invited to practice storytelling. And then there is a face-to-face in-person event where the learners participate in workshops, labs, and we attend lectures about climate science, sustainability, and so on. And we are talking about, consider that these are guys which are 15 years old, 16 years old, and it is not always easy to gather them, stay getting days very silent and attending the activity and the lectures. So there is a huge effort, and many people have to participate in terms of mentorship and as a facilitator. And the core areas, as I told you, are more in detail: climate change and sustainable development, eco building construction, because one of the objective of Agenda 2030 is about sustainable city. So eco building construction is very important. And then there is this 5 R's stuff, which is how to behave in connection with rules and everything in terms of rethinking, refuse, reduce, reuse, recycle. Okay, this is about waste, about an object, a computer, for example, that you don't have to waste it necessarily. You can rethink, reuse, you can do the note PC, for example. You can recycle, you can reuse, and so on. And then renewable energy, which is in line with the green agenda of the European Union. Let me talk a little bit about the engine of this project, which is the virtual learning environment. This is, of course, an educational environment. It is hosted on OpenEdX, and it is multilingual. And this is a screenshot of how it looks like. So the students, the guys can enter the virtual learning environment, which is online, currently active, and they can select various course micro modules. Okay, for example, this is the digital storytelling class that they are invited to attend online in these events the first 2 days. And if you access it now, I'm not able to show you directly, you can see that it is made up by a series of micro modules, which are essentially kind of MOOC, massive online courses, which are very, very diffused nowadays. But on a micro scale, it is 3 minutes, section 1. Then there is section 2, 3 minutes more, and 3 minutes, 2 minutes, 2 minutes. The course is a long one, but it is divided in micro modules. Okay, so you can just attend one, and you can stop, and you can attend the second part in next day, and so on. And this facilitates the access to this kind of content from these students. And so this is also because you can download these courses. The site is small, so you can download one by one, day by day. You can look at it at your convenience. And another, just as an example on how we can be inclusive, because one of the first most important goal is to be inclusive, because these people is very diverse, coming from many different places. And when you meet them in person, they are not willing to talk. They are just very shy, stay there, not even look at you. No? So you have to break the ice somehow. Then you have to get them confident to speak in public. And this is not always easy. It's very difficult to do that, but there are methods in pedagogic sense. And one very powerful technique is to orient learning in terms of storytelling, okay, from both sides. So I tell stories, no one teaching, there and talking. I can tell a story, and then I can explain them how you can build a very nice and interesting story about some subject, okay? And then they can become able to make storytelling, and storytelling becomes the way they talk, okay? Which is difficult at the beginning, but then results are very, very good because there is a rise in self-confidence, okay? And this is the precondition to get to reach intuition, okay? Otherwise, you do not think to anyone, okay? This is an example of method to reach intuition, and then there is a strong, strong role of mentors, which means that me and the collaborators and other people from the department, okay, from the institutions that have to be present there and taking care of people in and mind that this is very, they are very different. So the degree of difference between them is huge. So you have to act in many cases one by one, in a single student way. Okay, let me quickly conclude. This is the last slide. How can we say that this project will be successful or not? Well, the objective is to reach 500,000 learners. It's a huge number apparently, but if you make a nice work and you put an accessible digital learning environment, it is not impossible, okay, in principle, but there are some results already because, for example, the project it is exemplifies how the technology, the narrative, and collaboration can contribute to face this problem of the low higher education rate in migrants, and web-based education works. Okay, and the model that we realized is scalable, that can be used in different situations, not only for this. Okay, and which is a possible next step. A system that distributes credentials, okay, and a broader language supports, and to enlarge the number of partners. This is my final statement. So thank you for your attention, and that's it.
Any questions?
I might have one. You were talking about learning, right? Hybrid learning is online combined with face-to-face learning.
Yes, yes.
Okay, and
But this is on the way. The final legacy of this process will be this virtual learning environment where we are going to put all the also in-person teaching, okay, in a very well organized way. And this is after when the project expires, which is this year, at the end of this year. The very, very important results will be this virtual learning environment, which is web-based.
so actually you are now teaching face-to-face.
Uh,
And your experiments were with 500 students,
Well, we involved more than
refugees, for 500. Okay.
yes, yes.
And in the final test, you get something, or it's just now reserving.
No, the final. I mean, this. I'm not sure I understand the question, but.
I mean, did you find the effectiveness of this way, or
Sorry?
did you find the effectiveness of using this way? Teaching?
Yes, yes, yes. There.
How did you measure it was effective on the
No,
migrants?
the number of access, okay, and then we make some storytelling with the point because they tell you.
Did you get
how
feedback
you-
from them?
Yes,
Yes.
From, and the storytelling is fantastic because they record, for example, videos, and you can it, and they tell you how did they feel, how they are happy they achieved a certain level of knowledge that they hadn't before, and so you can have feedback continuously. And so that's why we use these modern techniques about this teaching, because they are also useful for feedback.
I'm going to ask you something. So you work with multiple countries, multiple European Union countries, and this is an international project. So
Not,
did you use like
not
this?
only European,
Yeah, of course.
European Union money.
Yeah. It's okay. So, so did you use the same content for each country, or did you change some of the contents depending on the culture of each country?
The format is the same. The format is the same, but and the subjects are the same. The way they are developed, it's
Each partner developed
yes,
some content.
yes.
Okay.
According also to the expertise. For example, if you are expert in climate science, you will bit more on climate science. In Perugia, we are more about maybe environmental chemistry and things like that.
Thank you so much.
Thank you. This is really very nice and very important topic. And I'm wondering, in this case, if we have just listed the programs like the sustainability, right, reuse, recycling. So it's all about the sustainable sciences, right? So in this case, how do you think the students are going to learn without having any lab? It's all virtual. So virtual classes means more theory. While this probably needs more practical, right? They need to go to the lab, they need to work on hardware, whatsoever. Is this okay?
Okay, when we are active in person, of course, this is not the case, but this is a limit of virtual environments. So you cannot have real labs, but you can describe how to perform experiences in a lab, at least. But if you ask me if it's going to work, of course, it's not perfect. It's not a bachelor degree in a material in a real university, of course. But it's something that can orient these guys towards STEM, okay, science, technology, education, so they can decide to go to university, for example. No? That's the point.
Maybe then you can extend it to those, as you said, more future collaborations. Those
yes, because as you can
diplomas, like,
yes, yeah. But the project expires, then maybe the consortium can renew, the project and make a new submission and ask for more money because, of course, there is also a problem of sustainability of the virtual learning environment. And, we need money for that.
Thank you so much. We can continue with the final presentation. Sarah. Yeah, just yours. Thank you so much.
Maybe this is yours. Yes. Let's organize. Let's share this. Let's share this. This is the last.
Yeah,
The research unsupervised learning. Nanometer response. Correction. Okay. I'm Sarah. Could you please introduce yourself?
Thank you. I will try to be quick because we're a little bit late. So, my name is Sarah. I'm from HSC University, Lambda Laboratory. And today I will tell you about using of WCAN architecture to try to correct the response of calorimeter. I think you are all from different backgrounds, so I will have a little bit of definitions because it's also like I'm more in the programming part. It's also new for me. So I'll start briefly by talking about the role of calorimeter in high energy experiment physics. So a calorimeter is very important for the high energy detectors. It measures the energy of the particle by completely absorbing them, and then it will record the resulting energy deposition that they got. It also happens across different layers, so it will give us not only information about the energy, but also about the spatial information, like where the particle was gone, where it hit. So, but the problem we are dealing with is over time, these calorimeters, they don't stay perfect. They have material aging. They suffer also from radiation damage. So this will make the measurement like biased and accurate. So this is also will be more if it's for long-term experiments like that happens in Large Hadron Collider. This where calibration methods comes. Calibration methods is in the step in the calorimeter is very important to do this calibration. So this will ensure that each cell of the calorimeter will give us the consistent output when it's subjected to the same input. So ideally, if the same particles hitting different cells, the output or the response of the cells should be the same. But that's not the way. It doesn't happen like this. Well, mainly because manufacturing variation. So in the beginning, each cell reacts slightly different when it's subjected to the same input. So we need to make uniformity across all these cells. So like we align the responses, so this will have like accurate results, accurate measurement, and reliable. Because now we will have very good reports on the analysis of physics of particles also, and for a scientific report which should be precise. We want to explore like applying a machine learning approach to fully automate this process of calibration. We mainly will use GAN to try to do this calibration. So GAN is a class of machine learning. It's a generative adversarial network. Short GAN is 2014, first time introduced by Goodfellows and his colleagues for sure. Mainly it's try to generate data sets that are similar to your training data sets. Mainly, it has like two components main, generator and discriminator. Generator try to generate data that resembles the real data, and discriminator will try to evaluate differentiate between the real data and the fake data that's coming from a generator. So this is terminology. From generator it will be fake because it's generated, and real data is our data. So in the training, this will try to generate better, more data similar to the real data, and discriminator will try to classify them from each other better. So the feedback from the discriminator that will try to make the generator work better to generate new data. We'll see how we'll deploy this. Usually, how they use calibration methods here, I'll try to be quick. There are hardware-based methods you introduce.
Slow down, you don't have to be
I'm
quick.
sorry.
Going.
It's not. It's just me. I speak quickly. I do everything quickly. Okay. I'll try. It's like if I will be slowly, I will
just a
I will not be thinking correctly. Okay. So we introduce electrical internal pulse to each cell, and we adjust the output and assess it of the cell's response of it. When I slow, I lose my thoughts.
No, you said
Okay,
we are in a hurry. I told you we are not in a hurry.
No,
Okay.
okay, thank you. to adjust and assess the response of these countries. So it's like introduced to standardized input. We'll try to make it. Also, sometimes you introduce other resources like laser beam, radioactive resources, like with known energy spectrum. You give it to the cell, like you know what you are giving the cell. So you also adjust and assess the output as it should be. Also, like test beam, you have controlled beam of particles that with known properties. It's this before the deployment of the calorimeter, before you start in using it in the real experiments. You also calibrate it through this method, and you adjust the response of the cells. Also, other methods like it's called in situ. It's like we use known samples in physics, like decay of Z bosons or W bosons. This will be just like a benchmark for the calorimeter, and we will try also to calibrate it through this. So we got our calorimeter. We used one calibration methods, or sometimes they used multiple of them. It's now using in experiments. It's good. We're not done because degradation is inevitable with time. What we call aging happens. Damage from radiation, like each cell starts to reach some of these energies. With time, it will degrade again. Like if it's, for example, the energy should be 100, it's treated as 99, as 80 sometimes. So this is the problem. It's like after sometimes. So if you all apply this again multiple times, so you will have like labor intensive for sure, time consuming, technical demanding, especially for example the hardware. You will need to make a dedication channels to each cell to deliver these calibration signals, and like a lot of troubles and a lot of time. So like that's why we want to introduce a software approach, because like we have a large parameter optimization problem, and for us data scientists, like we want to make again software approach that will to make this problem. So like we will not use all of this, and it's data driven approach. So we only have the data. We'll try to find our coefficients or we'll try to calibration. So here I will go into the terminologies. First of all, in simulation, we had 100K events. They are generated from 10 GeV single pions. These are the particles. We used a highly granular parameter geometry. This is typical for future collider experiments. So we introduced in our data sensitive aging. Each cell, we assign to it an aging coefficient. We will call it, or aging factor. This aging factor is linear, has linear dependence on the integrated energy deposition. So our calorimeter that has no damage, we will call it undamaged, or we will call it fresh or new. After we introduced aging in each cell, we will call it aging coefficient. If you will find this aging coefficient, we did our calibration. When we introduce these aging coefficients, we will have the aging effect. We will call it the damaged calorimeter or the damaged data. So like this is undamaged, damaged. And the thing we need to find is the aging coefficient. The aging coefficient is different for each cell that they introduce to us this shift. So here, for example, we see the plot of the sum of energy distribution across all events. First of all, if there was no damage, it will be the blue. After we make some aging, we got the damage. So like the calibration is we will need to find these parameters, aging coefficient, that they will align this distribution together. So like for, again, data sciences, first metrics we can use to, if you want to difference in distributions, is actually what's called Wasserstein distance. This is a metric, measures the cost of transforming one distribution to another. From this, it's coming to what's called Wasserstein GAN. This is the GAN. Wasserstein GAN is generative adversarial network. It's similar to this, but they replaced this word discriminant. It will now called critic, and it's usually try to minimize the Wasserstein distance between the real data and the generated data distributions. This is the architecture of it. this is our goal. So for our goal, we're trying to make this architecture that we will align these two distribution together, and we will try to minimize the Weierstrass distance between this between, let's just say, between this data, and this will be done by finding this aging coefficient. So this is our architecture. This is generator, this is critic. Real events will be like it with no change. But here, the uncalibrated events, it will go, well, technically you can just, I wrote it this way because you can try to make the orange to the blue or the blue to orange, it doesn't matter because it's the same coefficient will be. So one of them, let's suppose here will be the orange one, or like the uncalibrated method, damaged. Generator will try to find this coefficient and apply them, so we will have the calibrated event. And the real event will be without any change. So the critic will try to minimize the critic will try to estimate the Weierstrass distance between these two distributions. So in general, the generator will try to make as possible this calibrated event to be similar to this. Like in the end, it's all of in general of distributions. And the critic will try to give it like maximize this Weierstrass distance between them because they are adversarial. Everyone needs to beat the other, and this will happen in different iteration. So when we apply it so many times, we got this calibrated aging factor. So also I'd like to mention that in this architecture model, the real aging factor is not given to the model, so it's unsupervised. So here we got our results. This is the true, and this is the predicted. We're gonna see a correlation, almost aligned. This is the diagonal y equal x, so it's perfect if you will align on it. But we have a little bit of error, let's just say, between residual error. So we can distinguish, from this model, it's actually given us like it can learn meaningful pattern in this synthetic aging data, and this is support the feasibility of like just data-driven approach. So like we only have the data, and we can get almost to predicting the aging calibration. This is through the whole training process. This aging coefficient was not given to our model, but like we can just see it, and then we saw that it's actually have a trend of like after 60 months it's tried to learn. So like it's very promising. Yeah, and that RMSE of 2%. So it's stable during training. It's like not calibrated. Yeah, that was our original one. We found this aging coefficient, we apply them, and that's what we got after we calibrated them. So WGAM models actually can restore this shift that happens. So yeah, we think this is a step, good step towards like more autonomous calibration. Yeah. Now for our conclusion, for sure we reduced dependence and time consuming physical calibration, intense labor, and all the stuff. It's also only data-driven approach. We don't need a lot of evidence. We don't need to like have like so many experiments on the detector and all the stuff. So we can achieve like a potential to have a fully automated model, and yeah, for the future we can have more experiments even to like try maybe bigger dimensions or try different different specific aging and stuff like this to more be realistic to the real calorimetry. So yeah, this is my laboratory, and now we'll do your questions.
Thank you very much. Very nice thing, but I think maybe I misunderstand something. Could you please return back to the figure?
Is that working? Okay, which one?
The previous slide, I think.
This one?
Yes. The blue one is the correct result. Exactly. And the orange one is the damaged one, based on the degradation of the signal, affecting of the weather, the surrounding area, and so on. Manufacturing. We said it has no difference. if we make blue to orange or orange to blue. I think it has a big difference. Because actually you would need to bring orange to blue, not to blue to orange as you put there.
Mm-hmm.
What do you think?
Yeah, well, can I know why?
Because actually you wouldn't want to get the damaged message signal. You want to get the undamaged signal.
Yeah.
Because if you get the damaged signal, for example, from a sensor,
Mhm.
this means if the temperature is 30 and the sensor and the damage is 32, you might adapt it to 32 and it's actually should be 30. So it's a big difference.
Yeah, you're right. In the end, in the actual, for sure, I need the blue. But in our methods that we are trying to do, we're trying to find the coefficient that if we will apply them, those two will be together. So technically, in my methods, I have these two, the orange and the blue, and I'm trying to find this coefficient. When if I apply them, these two will be together.
You
So
should know to which line you should apply, either negatively or positively. Because if you apply randomly, this means you are getting another error. I think.
no, like these two are fixed. In the end,
Okay.
I will. I just need my coefficient. These ones. When I found them, I apply them. So if
Where to apply them? Where to the
to the rid of the sensors. Yes, to the output of the sensor.
to the output of the
Yes.
sensor, which
Yes.
means to the orange.
Yes.
So-
Yeah. This is when I need to apply them and read my my fancy.
And that-
But this is only for the process of finding them. This is only in the process of finding them. I'm not using them. I'm in the process of finding them. I can.
It doesn't matter for you.
Yeah, because like I have two signals. I'm just trying. This is only happening in my computer. I'm not doing anything there.
So next step, you will find out how to make it on the orange rather than the blue.
I can try this experiment to see how
Please do.
it affects. Yes.
Because it's very important.
Okay.
As far as I think.
Okay. Thank you.
Thank you very much. Any more questions? Any more questions? Thank you very much.
Thank you.
And this is the end of our session. I was pleased to meet you all. Thank you very much for being here.
Just